Alright, so today we're talking about altitude and leg proportions, and basically what these things is you start with one right triangle like this, and then you drop an altitude, which makes 90-degree angles right there. So this right here is the main diagram, and then I've broken it up into the triangle on the left, the triangle on the right, and the whole thing is right there. So we can see what triangles are similar to each other. So, for example, triangles that are similar to each other. If we look at the whole thing here, we look at angle C. Angle C has to be congruent to, guess what? Angle C in this one from the reflexive property. Whoa, cool! Also, if you think about it, since we already have a 90-degree angle and an angle congruent in these two triangles, then obviously this angle A here and this angle D would also have to be the same because the triangle adds up to 180 degrees. But wait just a second, because what that means is that since angle A is in both this triangle and this triangle, then angle A would have to be congruent by the reflexive property, and then while we're at it, just because of adding up to 180, this angle D would have to equal the same thing as angle C. So in the end, all three angles are the same in all three of these triangles, making all of them similar. So with this example right here, we're going to try to find the length of CD. And in order to do that, we're going to draw the triangles separately. And we don't have to draw all three of the triangles, because if you look at it, if we look at triangle ACD right here, and we look at triangle BCD, those are going to have the sides we care about. We got the 3, we got the x, and in the other triangle we got the x and we got the 12. So let's draw those out real quick. So if we look at our two triangles here, we have like the short side on each of them corresponding to each other, and we have the medium side, the non-hypotenuse side, corresponding to each other. So with this, we can just set up our proportion, same as what we've been doing before. And we have 3 over x, the two red sides, equals x over 12, the two blue sides. So let me just cross multiply. X times x is x squared, and then 3 times 12 is 36. To solve that, take square root, and you get x equals 6. So in this triangle, we're looking to solve for the length of QP, or R in this sense here. So to figure out which triangles we need this triangle, obviously, because that includes R. So if we take QOP, and we also would like to use this triangle because that also involves side QP. So let's draw those. Okay, so when we solve for this, I put 260 here because this whole side is 80 plus 180, so that would add up to 260. So then we match up the sides that correspond to each other again. So we have the leg right here, R, and the leg here, 80. And then we have the hypotenuse, 280, or 260 rather, and the hypotenuse here is R. So we can set up a proportion now. We got the red sides, R over 80 equals, and the blue sides, 260 over R. Cross multiply, you get R squared equals, multiply those, 20,800. And then if you take the square root, you get R is equal to about 144.2.